Bismillahirrahmanirrahim. Welcome back, guys. This is Shahfahadkhan. Okay, we are going to start out with an even more important chapter now. That is evaporation to dryness and crystallization. So we are going to start out with evaporation. Okay, guys. So now let's talk about evaporation to dryness. Okay, what do we mean by evaporation and what do we mean by dryness? Dryness means no water, right? Lacking water. But evaporation means evaporating all the water off of that solution. Evaporating means conversion from liquid to gas, right? Converting it from liquid to gas is the process of evaporation. And but the difference between evaporation and boiling is very simple. During boiling, the temperature remains constant, but during evaporation, the temperature does not remain constant. The boiling occurs at a particular boiling point, but the evaporation does not occur at a boiling point, but it can occur at any temperature. Okay, it doesn't only have to occur during the boiling point. Evaporation can occur during any temperature. Then after this, evaporation to dryness. Now let's read through this paragraph first and then I'll explain it to you what it actually means. And again, this page has been taken from the same book, Chemistry Matters. Okay. Okay, now when a solid is insoluble in water, the easiest way to separate it from a liquid is by filtration. But if the solid is not insoluble in water, rather it is soluble in water, then what will you do? Then this technique comes into play. Okay, evaporation to dryness. Like common salt dissolve in water to form solutions. To separate such substances, we evaporate water from solution. This separation technique is called evaporation to dryness. For example, when we separate salt solution to dryness, evaporate salt solution to dryness, we recover the solid salt. This method can be used to recover salt from the seawater. Okay, but guys, remember one thing. This is one technique of separating out. If you have a mixture containing solid and water, you can either filter it out if the solid is insoluble, but if the solid is soluble, then you cannot use filtration because it's soluble. It will just pass out the filtrate. Then what you could do is you could just remove out all the water that is present. And the easiest way of doing that is by evaporation to dryness. And as soon as you do that, water is removed, all the water is boiled out, it is evaporated out, then you will get solid powder. Okay, this is a key term. You will get powder. You won't get crystals. You will not get crystals. You will get powder form of your salt. For example, common salt. The common way of separating out common salt is by evaporation to dryness from the seawater. Okay, seawater, when it dries out, the salt is left behind. But let me tell you one thing, this salt is not very pure because any soluble impurity which was there in this solution would also be left with the salt. So again, impurity will still exist in here in this solution. How? Okay, and another limitation of this technique is that there are certain substances that decompose on strong heating. Okay, what do we mean by decompose? Here it is. When a substance decomposes, it breaks into simpler substances. Okay, and I'll just quickly give you one example. Do you know what calcium carbonate is? Calcium carbonate, what your marble chips are made up of, calcium carbonate. If you heat it strongly, you'll get two products. When you heat it strongly, you'll decompose it. You'll get calcium oxide and carbon dioxide. These are the two products that you'll get. This is also white solid and this is gas. Okay, this is also a solid. So this is decomposition. So that means it will, if you heat calcium carbonate, it will decompose on strong heating. So such substances, if are dissolved in a mixture, well, calcium carbonate doesn't actually dissolve readily in water, but still, if you have certain substances that are soluble in water, for example, magnesium nitrate can also dissolve in water, and magnesium nitrate on strong heating also decomposes, right? It also decomposes into magnesium oxide, nitrogen dioxide, and oxygen. But again, you don't need to know this definition. I'm just giving out this equation. Doesn't need to be remembered over here at your level because it's an equation from A levels. But just to explain you, just for the sake of explanation, that see, when you heat a substance, it will decompose, it will break down into simpler substances. Okay, so such substances, if are dissolved in water or if are dissolved in a solution, they cannot be separated out by just simple evaporation to dryness, because if you heat them strongly, in order, and you want to achieve this product, you won't get this product because that strong heating would have caused it to convert into other products. So again, evaporation to dryness. First, the substance that you get, the advantage is that you will get a solid from a solution which is soluble in water or soluble in that solution by evaporating out the solution. Usually this liquid is water, okay? And the most common application is recovering salt from seawater. That's the most common application. That's one application that will be asked from you on the exams as well, on the past papers as well. So you need to remember that to recover salt from seawater, you need to evaporate to dryness, and that will give you powder salt. But the limitation is that the salt will not be pure. There's no guarantee that it's going to be pure because any soluble impurity will be left with it. And secondly, that salt would be in powdered form. Thirdly, substances which decompose on strong heating, you cannot recover them using this technique, because if you heat them very, very strongly, they'll decompose into other products. Clear? I hope this makes sense. Now, moving on to the next para. However, many substances decompose, as we talked about, when they are heated strongly. For example, sugar. Okay, don't go far. Don't go into these complex examples. Just come to this simple sugar. Sugar, the table sugar that you have, the sucrose that you have. Sucrose, by the way, sucrose is your table sugar, okay? Sucrose is a type of sugar which you'll, if you have biology, you will study. But sucrose, or the table sugar, it will decompose to give water and carbon when it is heated strongly. Okay, and of course it's sugar, so it's made up of carbon, hydrogen, and oxygen. And as soon as you heat it strongly, it will decompose into carbon as well as water, because it has carbon, hydrogen, and oxygen. The hydrogen and oxygen will form water, and the carbon will move out. Just like this, if you heat it strongly in this china dish, it will turn black. Why black? Because the carbon has formed. And if you look at it carefully, it seems as if it's a bit liquefied because of the water that has formed. Okay, so the sugar will decompose into this thing on strong heating. So you cannot remove out sugar from its sugar solution. And the reason is simple, because the sugar, you won't get sugar, you will get carbon instead. Okay, when it is heated strongly, most crystals, such as copper 2 sulfate crystals, they would give off water to become powders when heated. And okay, that's a statement, and that's a fact, and that's what we'll be discussing in crystallization, not here. For such substances, evaporation to dryness is not a good method for purification. Okay, this is just an example that substances that give copper 2 sulfate is a very typical example, by the way. Copper 2 sulfate, this copper 2 sulfate is actually very frequently asked on your exams, especially in crystallization for formation of copper 2 sulfate crystals. And I'll just show it to you. This is how the crystals look like. Okay, and this is how the copper 2 sulfate solution looks like. We'll be talking about this in detail later on, meaning in the next video, when we'll be discussing crystallization in detail. But over here, for such substances that give off water on heating, or for them, this is not a good technique as well. Okay, evaporation to dryness is not a good technique for purification, because water will still be left if they give off water. Again, crystals won't be crystals anymore, they'll become powder. Again, we don't want that to happen. We want to recover crystals, and we won't get that through evaporation to dryness. Also, when all the water is removed during evaporation, any soluble impurities present will be left on the crystals. And this is what I was explaining to you, that after removing all the water, any soluble impurities, by the I mean any soluble impurities, especially in the case of seawater, you have a lot of other impurities in there. They'll also be left with the salt solution that you have recovered. Okay, so that's again a limitation. You won't get very, very pure substance, but you will definitely get something. You will definitely get a solid. Okay, and sugar decomposes under heating, and that's it. And that's everything about evaporation to dryness. Now we are going to start out crystallization, but not now, in the next video. So stick around and stay tuned for the next video.